Welcome, everyone. It's a pleasure to see you all again. Just there's a possibility we might get a very brief introduction. Thank you so very much. Student's wallet was found, and I emailed them and said I'm going to be in this room for an hour. If not, I'll find you tomorrow with security or something. So if someone strange walks in, it's part of the plan. Um, Welcome, everyone. And tonight we have, is there a place to watch? Yes, there is. All right, so a question on the chat, which is easily answered. Is there a place to watch the past lectures? Let's, say you miss one, or you're throwing a party for all your friends and you just want to have these going on in the background. So I have a YouTube channel at Dr. Jan 41, DRJAHN 41. And here we got all these kinds of things. But if you go to playlists, one of the most recent ones should be local wildlife and their prehistoric ancestors. So this lecture series is here. I write a newsletter for the Audubon Society, so there's a whole bunch of playlists that come out with each month, so like the videos that face each month. But if you look far enough behind, there was also another one from last semester when we had the one there. And I'm sorry, Barbara, I don't want to mute you, but I think there was something going on in the background.
No, that's another Barbara.
That's another Barbara. Okay.
See?
Okay. All right. Okay. So yes, if you'd like to see that, or you can always email me, walterjan@sunyorange.edu. Always happy to help. As we were having a little conversation earlier, you people being more in tune with nature than most, and I'm serious with that. Everyone else is like, oh, this winter. I'm sure a lot of you are like, ooh, spring is here because you're hearing the birds and you're noticing a few extra things. So, once the ice melts a little bit more, there's so many great places to get out and about. But then also, this is the last time to see the winter birds. So I was out yesterday, and the short-eared owls, that's a winter bird. You're going to see them in winter, otherwise you have to wait till next year. There were snow geese. I'm sorry, we still got. So I'm sorry, it's just, if anyone would like to speak, you're welcome to, but there's just we're getting some background music, noise. White-crowned sparrows, just all these birds that winter is the time to see them. So if you were out at the Liberty Loop, that would be a great place. The Audubon Society has field trips in about 2 weeks. I hope the snow has melted enough that we're starting to get some migratory waterfowl in Goshen at the Audubon Sanctuary. I'll be leading a nature walk there along the Heritage Trail, if anyone's interested. The Bashicle Area Association, once again, this sounds weird, but this Saturday, we're all about frogs and salamanders because there's going to come a time where it gets a little over 40 degrees and it rains. And that is the night, if you know your amphibians, that is the night where all of them are leaving the places where they hibernated. And they're like, let's go find a temporary pond where we can have sex, we can lay eggs, and that our larvae will develop before like all the, frog-eating birds come back from migration. And so there are nights where there are just hundreds and hundreds of salamanders and frogs crossing the road. Now, it's not just one night because like some salamanders are early, like bullfrogs will come a little bit later. So not only will we have a presentation on this at Meek on Saturday, but also we organize volunteers. If you would like to be one of those brave ones and on a rainy spring night, you are along a road helping salamanders cross the road so they don't get squished, you too could be part of this. But just a sign that, spring is coming. And even though, you think it's far away for frogs and salamanders, last year we missed it because, with climate change, we're used to March being our amphibian night. Last year, the big one came at the end of February. It was so warm. So, once again, it's time to get tuned in to nature again, as I'm sure a lot of you know. Tonight, as we continue on our series of looking at life and how it got here, we pick up where we left off, which seems weird, all right? Because last time we were talking about invertebrates. And tonight we want to talk about fish and the vertebrates and amphibians next time, reptiles soon after that. So at some point we have to make a transition between the invertebrates and the vertebrates. So that's kind of my job now. Now, a lot of you aren't quite sure how I'm going to do it, but those of you who are here for the song, you already know all the key points. So you heard about this. There are some invertebrates which share stuff with us that you wouldn't necessarily think that. So here, for example, we see a starfish. They're nice. All right, we see sea urchins. They're nice. But if you were to look at their embryos, if you were to look at their genes, their sea cucumbers in here, they share features with us vertebrates that the bugs don't and the mollusks don't. So in the great family tree with all the different groups of invertebrates, there are actually some which are more closely related to us than others. So that alone is interesting. And we could talk about echinoderms and their tube feet. That's just, echinoderms are cool. All right. So we talk about the starfish, and you can see all these little feet that they can squish water into here. But we should really leave them because they're kind of like a weird side branch of the family tree that just decided not to be bilaterally symmetrical, anymore. They had that weird, symmetry based on 5. So while they're interesting, let's leave them. And in one of my assignments for my students, I have a little cartoon, this one. And their assignment is, after watching this, them and their groups, they write why these worms suck. All right. And actually, that's really important. All right. So let me tell you why these worms suck. So here we have worms. And I'm sorry, you're feeling the same. You're thinking, last week, didn't we talk about all these worms? There were the flatworms, there were the roundworms, there were the segmented worms, there were those weird predator priapulid worms. You mentioned all these different kinds of worms. Here's another group of worms. But this one's interesting because if you look in their throat region, okay, we're going to look really close. We see slits. Slits in their throat. Now, believe it or not, I'm going somewhere with this. All right. Now, why do they have slits in their throat? Well, it just makes sense that if they can spend their days like this.
Hey, Sherry, thank you.
If the water comes in their mouth and it comes out the slits in their throat, this is just a feeding mechanism. They just got like a little vacuum cleaner going here and they eat. Now, I'm going to tell you how they eat. And this is actually going to come back around. It's going to be a callback in a way that you're not expecting. They have mucus, which lines their throat, and little critters that they eat get stuck in the mucus, and then they sweep it towards their intestine, and so they digest it. All right. So that's what they do. These worms suck. They are called hemichordates, and we still have a few alive today. And there were some alive in the early Cambrian that we know of. All right. So that's one thing. But then a little later, another group comes, and what they do is, I just have it. The next group, they decide, let's keep that, but let's put blood vessels at those slits. All right. So they're used for feeding. You can do this. Water comes in, it goes through the slits, and you catch little critters and mucus. But if you put blood vessels here, all right, now as the water leaves, guess what you can do? You can suck oxygen out of it. And we have a name for that. It's called a gill. Now, there's different kinds of gills, but this is the kind of gills that fish have. So if you later, after the first worm said, hey, let's get slits in our throat, if you said, hey, let's put blood vessels here, you can breathe. Now, I'm talking about slits in your throat. I'm not quite sure if I've got your attention yet. But these wormy things, we have a name for them. We call them chordates. And I have a word for you. I don't know if you've ever been called this before. I hope no one's offended. One of the words I have for you is chordate, where when we put animals into bunches, there are the arthropods that have like, spiders and crabs and bugs. There are the mollusks, which have, like octopi and snails and clams. And then there's a group of animals that we call the chordates. That would include us. It would include the fish we're going to talk about tonight, but it would also include these wormy things. that aren't fish, but start to have features of the fish. And here is a pig embryo. And if you notice, it has slits in its throat. So the slits in the throat thing, that's a chordate thing. The phylum Chordata, that's one of our features. All right. Now, the fish will put their gills there. We humans, we do that too. We have slits in our throat. All right. And then there comes a day where we say, like, what the heck am I doing? I don't want gills. And we reorganize it. And this would be a fascinating discussion, but probably for later. Like the crazy stuff that happens, you have all this cartilage to support these gills, or like these gill slits. And you say, like, what the heck am I doing? And you say, all right, well, tell you what, these will become the jaw. These will fuse with these and become the hyoid bone. These we make into the trachea. The thymus is up here, it should move down. The thyroid is down here, it should move up. And we reorganize this area, but it's crazy. And every now and then children have birth defects because like this area, like they still have a slit that's open or something, and this reorganization doesn't go quite to plan. But in other words, this primitive chordate feature of slits in the throat is something that we all share, even if we don't have it as adults. All chordates share this as embryos. All right. So there are invertebrates which are getting this fish feature. Are we done? No, not even close. So here are these hemichordate worms. They're called acorn worms. All right. But I'm now going to talk about this guy, a real chordate. And just to highlight this, I've got a video, but here you can see this. You and this leech move differently. Like, let's say the person next to you, I put rulers on the table and I say, all right, go to the person next to you and measure their back. So you measure their back. And I say, all right, now have your partner stretch their back out, measure it the same length. And I say, all right, scrunch your back up, measure it, same length. So it turns out our back stays the same length because we've got this rigid rod going down at the backbone. Okay. Leeches, they move differently. They can stretch out, they can scrunch up. Earthworms can as well. We, however, because our back is rigid, we now have muscles which if you pull on this side, it goes this way. Pull on this side, it goes this way. And if you keep on doing that, and if you're in water, you're swimming. So having a support rod go down your back, well, there'll be video in a second, is a way that fish swim that's different from the things we were talking about yesterday. So we have a backbone, but it turns out there's something that comes before the backbone. It's called a notochord, hence the term chordate. So here's a squishy little thing. It's an invertebrate about yay long. It has a notochord, all right? So it's got a stiff rod going down its back. And here is a fish we'll be talking about in a second called a lamprey. And you notice it has a notochord, all right? So these squishy invertebrates, they're not vertebrates, they're not fish, but they have the same primitive rod going down their back as the first fish had. Backbones will come later in gradual steps. So there are invertebrates that have the type of gills that fish have. There are invertebrates which have this bony rod that goes down their back like fish have. I would love to, just in the interest of time, we can't talk about the notochord forever. But we had a notochord. Your notochord as an embryo was really important. It told your nervous system, hey, I'm the notochord nervous system. You should be forming above me. It was secreting a hormone to do that. So those little squishy things have notochords. The primitive fish that don't have backbones have notochords. We as embryos had notochords. There's more. All right, but we want to get into fish, so we'll zip through this. All right. All right, so here is those throat slits in vertebrate embryos. I'm pretty sure that's a chicken. Here's a pig. Okay. Now, a question that we could have asked last week but didn't. But I could have asked the question, where is the anus? In general, the anus is usually at the end of the body. So you look at a dragonfly, where is the anus? It's at the end. Where's a spider's anus? It's at the end. Where's a crayfish's anus? At the end. So the digestive system, the intestine, just runs the length of the body. You go to the vertebrates. Where's the anus? Not at the tip of the tail. All right. So think of a cat. Think of a horse. Think of a snake. All right. Think of a fish. The anus and the digestive system kind of ends there. And then there's this tail that's just there full of like muscular and skeletal elements. So there's a post-anal tail. Beyond the point where the digestive system ends, there's more muscle, et cetera, that's just for propulsion. These squishy little chordates get that. All right. So this is a feature that we associate with the vertebrates, but these squishy guys get it. All right. There's more. You see this white rod of a nervous system? It's on the back and it's hollow. You look on a crayfish or an earthworm, it's on the front and it's solid. These things, they've got a homologue of the liver. These things, they have a homologue of the thyroid gland. I'm just going to stop. The point is, there's all of these invertebrates. We talked about a gazillion last time. But this group we left out because this group has features of the fish. And we have them in the fossil record right at the beginning of the Cambrian from 530 million years ago. So these have some, but not all of the complexity of the fish. It seems that fish level complexity was built in stages. If you missed any part of that, then obviously you know what to do. You can go back and, oh, where did I put it? There it is. You can listen to the chordate song all over again, and now it'll make sense. But I'll leave that for you to do later. All right. Then a new group develops, all right, and they're special. So we'll play a little of this song. I swear.
My brain is so much bigger than yours. My brain is so much bigger than yours.
So a new group appears. A new group, and I want to say evolves from the invertebrates. But see, I'm really kind of splitting hairs right now because I'm going to start talking about fish. The most primitive fish alive today, we could call them invertebrates. So, if you were to ask the question, could, an invertebrate evolve into a fish? Well, that's the most primitive fish alive today, a hagfish. And I mentioned last time that the geneticists, the anatomists sometimes argue with each other. This would be a good example of that. Whereas as an anatomist, I would say these guys are more primitive than lampreys, and then you have the sharks. Whereas geneticists would say these guys and lampreys are equally related to the sharks. So I don't want to argue, but just so you know, when you analyze data from two different fields, sometimes slightly different answers. Anyway, so this is a fish. When it was first discovered, it was described as a worm, and it is the most primitive thing alive today. Like, I teach comparative anatomy. I would love to go into how primitive its brain is, not having a cerebellum, how primitive its kidneys are, still using the pronephros and not being able to change the concentration of its body fluids. It doesn't even have blood vessels that go to its heart. So its heart has muscle, but doesn't have blood vessels, so it doesn't work very well. I could go on and on. Those hagfish are very primitive. This is the squishy invertebrate chordate I was telling you about a minute ago. This is a baby lamprey. And I hope you see, wow, they look a lot alike. All right. So somewhere in the Cambrian, little guys like these became little guys like these. Or to be more specific, little guys like these. These are the first fish. So 4 billion years of Earth's history passed with 0 fish. And if anyone feels that that's not true, well, once again, science, this is what science is about. If you have another idea, more power to you. Go out, test it. If you think fossils exist, fossils of fish existed in the Precambrian, good for you. Please go find them. You'll be front page news tomorrow. No, I mean, seriously, that's what science is about. Like, if you have an idea, I think my teacher's wrong, I think there's something more, good for you. Go out and test that. And if you turn out to be right, well, thank you, because we were teaching something wrong and you corrected it. Like that's great. But no one has found any fossil fish older than 500 some million years ago. And they're this. So what are they? Well, to describe them, they are an inch or 2 long. They have no jaws. They have no bone. They have no pectoral or pelvic fins. And they look like the squishy invertebrates. So once again, in time, all right, so the Paleozoic era starts with what's called the Cambrian period. This is when we get the first fish. And there's a couple fossils that look like this, and a couple's not what you really want, but there's hundreds and hundreds that look like this. So they swam in schools, and we have schools of those. So that's great, because now you get just more fossil stuff. Once again, the Earth has fish on it for the first time in history, but there are no bass, there are no trout, there are no sharks, there's nothing that looks anything like them. They're this big. They have no jaws. We'll get to that. They don't have pectoral and pelvic fins. So you say, oh wait, yeah, I see fins on the front and the back. I don't care. And not to be judgy, I care about some fins, not others. The ones on the back, who cares? Right? These fins and these fins, I care a lot because next week I want to talk about arms and legs. All right. So these fins on fish, these fins on fish, the pectoral and pelvic fins, I care about those. And these fish have none. That would come later. They have no bone tissue. Their skeleton is just cartilage. All right. So that's interesting. And today, not only are these the first fish and the most primitive fish, today we still have two of them alive today, the hagfish and the lamprey. And when I say two kinds, there's different kinds of hagfish, there's different kinds of lamprey, but you kind of get it. So, it's not just one. The hagfish, they live in the ocean at the bottom. Their metabolism is the lowest in all. Once again, do you want to call them a vertebrate? They don't have backbone. So like if vertebrates have vertebrae, they don't have it. So technically these are invertebrate fish. All right. I would love to tell more about them. They're kind of hard to study though, because they don't, they aren't raised in captivity. So let's talk about the lamprey. This is the next bunch up. So they have mouths, but they don't have jaws. All right, so they just like attach to something and they suck on it, or they have a raspy tongue. So if they found like a carcass of like a dead fish or something, the raspy tongue could like scrape the flesh and then they could kind of like suck this in here. So these are jawless fish. The first fish were jawless, and the most primitive fish alive today were jawless. Are lampreys vertebrates? Well, here's the thing, all right? And once again, there's a paper I read that maybe you want to argue that hagfish have a little extra something, but so in general, this is like the best answer, but we could explore this a little more. Hagfish have cartilage. They have a little cartilage in their head, but if you go to their tail, you see all these little rods of cartilage. Ooh, look at that. Cartilage in the tail. That's cool. But that's not a vertebra because vertebrae have to be down the back over the spinal cord. That's a vertebra. So this looks cool. If you could put that along the spinal cord, you'd say, "Ooh, look, you got beginnings of vertebrae." But hagfish don't have that. All right. You go to lampreys, however, and they do. So lampreys, they have oh, that's the hagfish. There's a notochord. Here's a lamprey. Once again, there's the notochord. That doesn't have a backbone the way you think of one. But I'm not being judgy. Backbones will actually take like 300 million years to get to the point where it is like the one you have. So backbones came about really slowly and gradually. But if we start on a lamprey, this is its gill arches and cartilage here. Here you can see the notochord. All right, now I'm going to get really excited, and I bet money that you're not, but just pretend that you are. All right, here's the notochord. Can you see that little thing right there? See that there? See that little thing there? See that little thing? That's cartilage over the spinal cord. That's the beginning of vertebrae. Now, you're not impressed, but that's okay. They had to start somewhere. So vertebrae were not a thing of the vertebrates at first. But from these very humble beginnings, the notochord was the support rod. But then it started to develop little pieces of cartilage above the notochord, then little pieces of cartilage below the notochord. Then the cartilage got bigger and bigger. The parts would stick together. It would convert to bone. Once again, I teach comparative anatomy. I'd be happy to talk about the evolution of the vertebral column, but that would be kind of like a separate talk. It happens very gradually. And so these jawless fish, all right, they start that process. Now, there's more jawless fish. However, we should probably take a little aside because we still have lampreys. And with spring coming up, it's kind of, we have lampreys here in our rivers, the ones which communicate with the ocean, like the Delaware and the Hudson. And something I was very surprised to find, you can catch them with their bare hands. Like if you find a little stream, you can just go down and hold this, lamprey, and it's kind of fun. No, I put it back and you're thinking, don't, it's a parasite. I'll explain in a second. I'm not advocating this, but like if you hear like, I'm not into this, but like the royal crown, like when the king was like lamprey pie is like the biggest thing in England. But if you watched what was it, Game of Thrones, Also, do you remember that was a big thing? Lamprey pie was a big thing. So anyway, there's a thing with lamprey pie. I've never had it. So we have lampreys all around the world. They are jawless fish. So once again, them and hagfish are the most primitive fish alive today. Here you can see their gills. They don't have jaws, so they're just sucking through their mouths. Some of these are free living, so they're not parasites. They're just sucking in ocean water, filtering stuff out. A number are parasites where they can like latch onto a fish, make a hole, and just suck out all the good stuff. So really bad, but I guess we don't really care most of the time because the ocean's full of fish and they're in the ocean and we don't really know much about them. So they're just doing their thing. They come up our Delaware River. That's where I know them best, and into all the tributaries, and they lay eggs. So this is a female lamprey. Each one of those dots is an egg. She can lay hundreds of thousands of eggs at a time. So in one season, hundreds of thousands of eggs, an enormous number. All right. So they're coming up here to spawn. Should you kill them because they're parasites that latch on to fish? Well, I mean, you can. I've seen fisher people do that. But to be honest, by the time they come up our rivers, they're adults. They're just trying to like mate, lay eggs, and die. They're done with the eating. So they're not going to latch onto any fish in Orange County. They're latching on to fish stays are done from the ocean. Here's one hiding underneath the stream. Once again, you could just go up and grab it. And so here, they are food for Orange County animals. When they lay their eggs, those little baby lampreys are now food for our bigger fish, etc. So they're actually part of our ecosystem. So if you let a lamprey live, that's probably going to screw up ocean fish a year from now as they like latch onto them, but it's not going to hurt anybody in Orange County, right? Because they're just parts of food chains here. They're not really parasites here. All right, so it'll be like a year, like 12 to 18 months before they parasitize fish. Now, each lamprey can kill 40 pounds of fish, all right? So that would be really bad in the ocean, or some of you may know where I'm going with this, or it could be really bad in the Great Lakes. Because as humans kind of, changed waterways and said, oh, wouldn't it be cool if we could kind of go around the, so here's a lamprey caught just swimming around. Go around the, you know what? I'm sorry. So that may not be my lamprey video that I want to show you right now. This one, yeah, okay. So as we said, oh, let's go around Niagara Falls. Let's like make it easier for boats to go this way. Now all of a sudden, lampreys got in the Great Lakes, and our lampreys in Orange County, their little babies will gradually swim down to the ocean where they get big and they parasitize fish. But in the Great Lakes, they said, we can get big here. And we can parasitize, we can complete our life cycle without ever going to the ocean. We can do all of it in the Great Lakes. And now this became the problem because now they can parasitize all of these. So it was, there was a canal in 1829 that went around Niagara Falls. In the 1920s, things were first seen in, lampreys were first seen here. In the early 1900s, one of the Great Lakes could produce millions of pounds of lake trout. All right, so if you lived around the Great Lakes, fishing for lake trout, that was a huge industry. Now, after sea lamprey infestation, harvest could be now hundreds of pounds per year. Today, when they're caught, most fish in the Great Lakes have scars from where lampreys have attached to them and parasitize them. And a couple of trout relatives have become extinct from the Great Lakes, like some of them were called ciscos. This is still important. The Great Lakes fisheries currently employ 75,000 people producing $7 billion of produce a year. And there are lampricides, pesticides, which are sprayed to kill the lampreys to help protect this industry. Okay. So kind of an interesting story. We're kind of tracing the history of vertebrates and fish, but one of the two jawless fish, the most primitive fish alive today, lives in Orange County and poses a major risk to the northern parts of New York. So a little aside into that. But if we were to leave the lampreys and to then go back, right? The jawless fish, for tens of millions of years, they were the only fish. Let me just repeat that. So for tens of millions of years, the only fish are jawless fish. Now, they get better. Now, I'm not criticizing the lampreys, but these guys get better. They get bone. You look at that big solid head thing, that's made of bone. So these jawless fish, now the later ones have bone in the head, cartilage everywhere else. Now, one of the reasons I'm really impressed with that is because when I was an embryo, guess what I did? I put bone in my head and had cartilage everywhere else. So when you were born, you had a skeleton that was part bone. Everything else was cartilage, which would gradually become bone. And if we study the fishes, they start off with bone in the head. Everything else is cartilage, but later groups of fish turn it into bone. So just the fact that your embryological development mirrors that, that's cool. All right. A lot of these jawless fish, they're flattened, spending a lot of time on the bottom. Like if they don't have jaws, obviously, they're, feeding on detritus and the like. So there's all of these jawless fish. Okay. And yeah, I went this way. But like I said, they get bone tissue and they put bone in their head. Some of them get, look at that, pectoral fins. Once again, I'm excited about pectoral fins because I love shoulders and arms, which we'll be talking about later. All right. So even though they don't have pelvic fins yet, they have pectoral fins, a few more advances. So fish are getting better. All right. Now, for those of you who have been, I'm guessing that's most of you, seeking an explanation of all of the songs, here was the third song that got played.
No one moves from my chest with balls. No one's afraid of a dog claws. No one's afraid of Chalice array. Everything's invertebrates have their jaws.
I would argue that in the 500 million years of vertebrate history, the number one most significant event was Jaws. Before Jaws, vertebrates were food. All right, they lived in a world, we talked about it last time,
Right.
8-foot-long sea scorpions. Some of the armored squid could be 12-foot long. One was, they think, 30 feet long. Invertebrates ruled. And these vertebrates, they were little things, squishy things with no jaws, sucking the ocean water. But when they got jaws, that changed. So within the vertebrate family tree, hagfish and lampreys are fish, but the jawed vertebrates, which we call the gnathostomes, they are more closely related. And they share features. This would be another lecture, but like if you were to look at a lamprey and a shark, there's so much you share with a shark, with your heart, with your antibodies, with your brain, with your that you don't share with a lamprey. All right, so we're a group, we jawed vertebrates. All right, that would include the jawed fishes. All right, where? I'm sorry, I've got. It's not jumping. Where did it go? I'm sorry, I'm just. Maybe it's here. Okay, we'll talk about it here. I've got so many videos that when I'm like, I want to show this one, I can't see it. Where did jaws come from? Well, it turns out those gill arches had cartilage in them. All right, so they actually had cartilage-like tissues before there were even fish in those invertebrate chordates. The lampreys and hagfish, they have cartilage here. And then what just happened is the first two gill arches just became bigger, stronger, and mobile so that they could move. So when you look at a shark, all right, here you see gill arches made of cartilage. There you see jaws. They're the same tissue, the cartilage. What you just had was a series of gill arches. Then you just had these get especially big. So whether it be like embryology, you could search sharks. A jawless fish would look like that, with those being the cartilage of the gill arches. And what happened was the first two became the upper and lower jaw, and then in sharks, the second one is called the hyomandibula. It's a jaw support. So vertebrates got their jaws, but just by taking the cartilage gill arches that they already had and then modifying. And this changes everything. Now, when jawed fishes appear, we're not going to talk about sharks just yet. There's another group called the placoderms. Placoderms are the first jawed fish. And there's little ones that are minnow-sized. There's these flattened ones. Those are the minnow-sized ones. Flattened ones that live on the bottom. And these guys, they're 30, 40 feet long. You know, those sea scorpions and armored squid, they're now eating those. Jaws changed everything. I would argue that nothing in the history of vertebrates changed their role in ecosystems like this. Vertebrates have ruled ever since. Who's at the top of land food chains? It's the people, it's the lions and tigers, it's the eagles, it's the snakes, it's the vertebrates with jaws. Who's on, the top in the ocean? It's the killer whales, it's the sharks, it's the vertebrates with jaws. Vertebrates rule the world now. And it wasn't that way until they got jaws. So placoderms were the first jawed fish. Heck, this one probably, look at those big bony front limbs. It could probably even come on land and move around a little bit. So these placoderms, I love them. They're great, but they die. Right around the time where, another little aside, there were places in Orange County. One of the gentlemen who was at our first lecture said actually on his property he had a big fossil rock with trilobites, etc. Orange County was the bottom of the ocean. Okay, and there are places you can go. Port Jervis has a couple of places where you can still find the remains of reefs from when that was the bottom of the ocean. And right around the time when Orange County was becoming raised because Africa hit us, or maybe we hit Africa. I wasn't there. I don't know whose fault it was. But in any case, when these two continents came together, what was the bottom of the ocean then got pushed up. And so that Orange County, which was the bottom of the ocean, is now land. Bunch of bad things were happening at this end of the Devonian. And the placoderms, which were the world's most diverse fish, they all died. So I'm sorry, I'm just gonna mute someone if I can find that. Sorry. So placoderms are gone, but sharks are now with us. All right, so here's one more. So we got all these placoderms. This one had these big fins with a joint in it. It was probably not only pushing itself along the bottom of land, but it's been found on the bottom of the waterways as well. But it's been found on land as well. So it was probably crawling on land a little bit. All right. This placoderm, fairly recently discovered, it's this primitive extinct group starting to show some of the features of the bony fish. So that's kind of neat, right? Just like we were saying, like, those chordates were kind of partway in between these and this. So here's a primitive fish. And when I look at all of these bones I've colored in here, I think, wow, I like that because my skull has those as well. So we're starting to see some of the things here. And in these early jawed fish, one group develops which we call the sharks. Some of them still retain bone in the fossil record, at least a little of it. The modern ones, they've lost the bone that their ancestors had. And so there were a lot of these. Now, today, we don't have that many kinds of sharks, and they all kind of look the same and swim the same. It's the bony fish, which are really diverse. But back in the day, bony fish had yet to take off. So sharks were the thing. There were sharks everywhere. All right. They had all these different body shapes. They had all these different ecological roles. Xenacanthus, the one I just showed you, and the green one at the bottom, lived in freshwater. All right. Today, like, sharks really aren't a freshwater thing. They used to be 12-foot long sharks, major predators in water. So if you're looking for the most primitive jawed vertebrates alive today, it would be the sharks. Okay, so the placoderms are dead. Another group called the acanthodians are dead, and the bony fish are a little more developed. We'll get into them in a second. All right, so we've got all these kinds of sharks. They do vary. All right, they do, have different lifestyles. So we have, hammerhead sharks. There's some really big ones which are filter feeders, and some are really flat. All right, so here you can kind of see one that's kind of flat on the bottom. It's got a shark-like body. But then some went a little further. See, that one's kind of flattened. And they decided, let's make ourselves even flatter, and they became what are called the rays. So rays are flat sharks. And instead of swimming like this, where they're swimming side to side, now they keep their back still, and these really big pectoral fins that just kind of wiggle and then let water go over them. So the cartilaginous fish would give us all these different kinds of sharks. it would give the rays. And there are some deep water cartilaginous fish called chimeras, which are still alive today. So that is um, a third group. If you ever go scuba diving in the rays, I'm sorry, scuba diving in the Caribbean, rays are pretty easy to find. All right, so here are eagle rays. Those are actually harder to find, so that's kind of cool. All right. A lot of times they'll like sit on the bottom so that, all right, so like they'll just kind of like shake a little bit and have sand disperse over them. But then if you disturb them, they're swimming away. So once again, it goes snorkeling. We're scuba diving in the Caribbean or in Florida. You might see some of those. The modern sharks really kind of get their kickoff in the age of dinosaurs. So there are sharks on Earth for a couple 100 million years in the Paleozoic, but they're not the sharks of today. You wouldn't have seen any shark alive today. And there's this big mass extinction at the end of the Paleozoic, and all of these old sharks die. All right, but then a new group evolve in the age of dinosaurs, the Mesozoic. And it's from these that we start to recognize, oh, that's kind of like the lineages alive today, including today, there are sharks which are 40 feet long that are filter feeders. Great white sharks aren't quite that big, but great white sharks did have an ancient relative which got to be that big. So there were 40-foot long relatives of great white sharks early in the age of mammals, which was around the time that like the ancestors of whales were starting to say, hey, I'm a mammal. Let me see if I can experiment in the water. A lot of the early elephants were experimenting with the water, the manatee relatives, etc. And so just at the time that all of these mammals are like, maybe it might be fun to live in the water, there's like these 40-foot long predatory sharks, probably feeding on these mammals, among other things. Okay. Now, not to be judgy, but in all of the fish, the bony fish have more in common with me than the sharks do. So once again, if we're kind of looking at the great family tree of life, here are two kinds of bony fish. And notice they're in a group with me called the osteichthyans that we don't have with with the sharks, etc. And when I look at them, they're just, not to be as egotistical as I am, so I'm sorry about this. But like, I look at their heads and I'm like, ooh, look, parietal bones. I got that. Oh, look, nasal bones. I got that. All right, look at these, the jugal bone, the maxillary bone. So once again, I like myself. And when I see these bony fish, I'm like, ooh, I like you guys more. I have more in common with you. In fact, if we were to take all the bones of a fish skull and paint them all these different colors, so give me a second, I'll paint them all these different colors. So here's a fish skull. Actually, I should back up a second. There we go. Yeah, so here's a fish skull, and you got all those little pieces and all little colors. Next week, I want to talk about the amphibians. So you're thinking, how on earth could you take a fish skull and turn it into an early amphibian skull? Well, the answer would be, just keep all the same pieces. All right, so you lose the gill supports. They go. But other than that, you just gotta change all their relative orientations. And if you want to take an amphibian skull and make it into a reptile skull, well, you just change it a little more. Right? You can even add a curve and make it into an early mammal skull like that. And so I look at these bony fish. All right. And once again, not to be egotistical, but I'm like, ooh, I know you. I know all these bones. So the first bony fish are not bass and trout. There are these weird things that actually still have shark features. I'd be happy to go through, but just probably not our best use of time. We'd say, oh, look, they have an eye stalk. Ooh, they have this pectoral spine. That's not something other bony fish have today. That's something that the sharks have. That's something that the placoderms have. When the bony fish start, there are already two kinds. I'd like to talk about this kind tonight because they make up almost all of the fish. But there's a second kind that develop lungs. And I'm not exaggerating because there are fish alive today called lungfish because they have lungs. And I'm not saying, ooh, they're kind of like lungs. No, they're lungs. They're really good lungs, actually. And so there's a second group. And probably won't work in tonight. This will probably be the kickoff of next week, the type of bony fish which lead to amphibians. So we'll talk about this group now. When that group starts off, the ray fin fish, they look sharky. Like, look at that body. That looks sharky more than it does like a sunfish or a goldfish or anything. See how long it took it to turn around? Like bass and goldfish, I mean, they can just stop dead and they can just turn right away. Sharks, they have to like very gradually make this broad arc. So this is a bony fish called a sturgeon. All right. We only have a couple of the most primitive bony fish alive today. Sturgeons are one. Gars would be another one. There's a group in Africa called the bitch ears, and then there's a slightly more advanced group that we have here called bowfins. I'll mention that. So sturgeons, which are kind of like a symbol for the Hudson River because they can just get to be huge, huge fish and are protected because, you know, how old they can get, just how big and grand they can get. These are primitive fish. Now, I know you might not like super care about like us ranking fish, but maybe you'll remember this. Let's look at fish scales, right? And if you say, all right, let's look at them. Why are they so white? Well, this would be another story, but where did fish, actually, I'm about to lie, so I'm going to tell you something that turns out it's not true. It's actually the opposite, right? Where did fish scales come from? Why are they so white? Because they're made of enamel and dentin, all right? And they have a little bone underneath that. Fish scales are made of tooth stuff. If you've ever touched a shark, like you ever go to like some theme park and they have a little park, you know, where you can like, you know, feed a shark, little shark throat. They're slimy, right? Is everyone going to correct me? Sharks are slimy? No, it's like sandpaper because they've got these little things. It's little teeth, all right? Fish scales start off as little sharp teeth. All right, so shark scales should be somewhere in this video. I swear they should be. Oh, fish scales too. No, they're in the previous video. I'm sorry, I lied. Anyway, so shark scales, they're tooth stuff. In fact, that's where teeth came from. It's not actually that scales came from teeth. It's the reverse. Joel, this fish, had scales made of tooth stuff. And then the ones near the mouth just got bigger and pointier to help grab prey. Right? So you can see that in sharks if you look at shark scales. And you know what? I'm sorry that I'm not showing it to you. I'll show you shark scales in a second. But if you look at the most, I forget what I would have called it. Shark, caudal fin, shark, placo. There we go. I was like, there's a name of it.
Swamp layers on it.
We'll get there. There we go. Right. So these are what shark scales look like, and they're pointy. And they're made, they have enamel and dentin, the same thing. And they have the early ones had a little bit of bone at the base. Teeth were derived from scales near the mouth. And if you were to look at sturgeons or gar, once again, these are the primitive bony fish, they still have that. They still have scales made of tooth stuff. Most fish say like, well, look at how you swim. All right, look at, you know, this sturgeon swimming. It's not fast. It's not really maneuverable. So yeah, it's great to have all this armor, but obviously, you know, it comes at a price. So the most common group of fish, they've lost that. But the most primitive fish like sturgeons and gars, they still have that feature. Okay. I don't do so much fishing anymore. Kind of like vegetarian, but like the one thing I've never caught is I've never caught a bowfin. I've seen them in the Delaware. I've gone looking for them in the Bashakill, which is a great place to find them. So here, if you have sturgeon, gars, and bitch ears as the most primitive bony fish alive today, who's next? Bowfins, and they live in Orange County. So that's kind of neat. So here's a bowfin skeleton. And once again, if you want a primitive bony fish, this is the next group up. They're called bowfins. This is a dead one I found in the Delaware. I think a fisher person caught it and then killed it. But you can see it's got this one really big dorsal fin, hence the term bowfin. So very primitive. And so what I'm going to say, it's not really all that weird, but you're probably not that familiar with it. A lot of the early fish, they just have like huge teeth in their jaws, or like just like fang-like stuff. Like we don't associate like fangs with fish. But a lot of them have it, especially on the roof of their mouth. So did the first amphibians. And so both ends, like they're kind of intimidating with all of their teeth. Okay. So we're going along, but like if you're not all that impressed, like I get it, because the world is still in the Paleozoic. It's got all these sharks. There's bony fish, but they're just one of many groups. But then there's that big mass extinction, all right? And then a new group comes. And now all of a sudden, in the age of dinosaurs, for the first time, oceans start to look like this, full of these bony fish, which are super maneuverable. All right. They don't have that heavy armor anymore. But if you look at how they change direction, sharks can't do that. Sharks can't stop. They can't hover. They can't turn around. They have to just make this really broad circle. These guys are just really good at swimming. Just look at the maneuverability there. There's a couple of reasons for that. All right. And I have videos, but maybe I can find it a little faster this way. Yeah. So one of the reasons is if you were to dissect a gar or a sturgeon or a bowfin, notice this bag hold a swim bladder. So if I'm a fish, that's a big bag. It goes from here to here. All right, so I'm not talking about like some tiny little organ. There's a little bag like a gallbladder. No, like there's a big long bag that stretches the length of the digestive cavity. So that's pretty big. All right, so that is a gar. Here's a bowfin. All right, and it's got all these divisions in it. They breathe air with these. All right, now I know that sounds weird, and I don't want to steal the thunder of the next lecture. All right, but okay. There are fish that breathe air, right? And there are fish that have lungs. So here's a lungfish. Here, it does have gills, but it says, no, the gills aren't working. I'm not getting enough air. So I'm going to go up to the surface. I'm going to take a gulp of air, and I'm going to put it into a bag. So the bony fish, at their start, they've got a bag that they can use to breathe the air in. And the lungfish, which we want to talk about next time, they say, oh, you know what would be really cool? Let's take that one bag and split it into two and make the blood vessels bigger. Now we got lungs. So what used to be a bag then splits into two bags, which then become lungs. And when we talk about amphibians, it turns out the lungs that they will need already existed in their fish ancestors. But most fish decided, no, let's go another way. Got a bag of air? You know what that would be good for? It's buoyance. All right, let's just not breathe with it. Let's just keep it as a bag of air. But now, like, you know, we can float. And we are more maneuverable. And this is the big thing that makes a group of fish called the teleosts. Every fish pretty much that you know that's not a shark or a lamprey is a teleost. They are just everywhere. All right, so, you know, bass are teleosts, sunfish are teleosts, just like most of Earth's fish are what are called teleosts. And they just share these features. They've got these bags, they're more maneuverable, etc. Have they always existed? They have not. So teleosts, all right, they are first appearing in the age of dinosaurs. So as we go up through here, we can have the bony fish here. All right, the group that gives us the bowfin comes here. But it is until the Mesozoic era when we get the first teleost fish. And if you're asking, when do we get the first bass? That's not until like after the dinosaurs are long gone. Like no dinosaur ever ate a bass. They didn't exist yet. All right, so the bony fish, they developed in all of these groups. Now, Orange County is awesome. And so maybe just as we're in this group of the bony fish, so there's one group that I'm not mentioning. They aren't common today, but like lungfish and coelacanths, they have true lungs, and you know we could talk about them with amphibians. Most fish are called the ray fin fish, or the fancy word is actinopterans. So what I like to end with is just Orange County. What do they look like? What kinds of fish could we find here? Well, one kind are eels. Right, so we have eels in this group. I swear. And if you like snorkel in the Delaware, like if you like get tubes, tubing is fun on the Delaware. If you just got like a little face mask, every now and then you can see some of these guys underneath you. These are interesting because, like a couple other fish I'm about to mention, part of their life cycle is completed in the ocean. So we know that birds migrate. It's like, oh, okay, this time of year they're migrating this way, they're migrating this way. Fish migrate, some of them, all right? So some fish are migrating from the ocean up our rivers, like lampreys and shad, so they can lay eggs here. Whereas the eels, they go the opposite direction. They're going to go into the ocean as young and then come back here when they're older. All right. If you don't know about shad, let me just tell you a little bit about them. Once again, a type of fish which completes part of its life cycle in the ocean. So right now, there's a whole bunch of shad in the ocean. And as it starts to get warmer, they're going to say, time to go back to Orange County. So they're going to swim up the Delaware. And if you're a fisher person, they say, where is the shad run now? Oh, it's in Philadelphia now. All right. And 2 weeks later, it's in Easton now, where people are following, like, I want to go fishing for shad. And you can follow it up the Delaware River as it gets closer and closer. And if you go kayaking along the Delaware, all of a sudden there's like all these fish swimming on the surface, swimming upstream. They're coming up here to spawn. All right, some of them will survive the experience, but because it's so hard to swim the length of the Delaware, mate, et cetera, some of them, this is the end of their life. They mate, they produce a lot of eggs, and then they die. Now, there are so many of these fish. George Washington's army after Valley Forge, they ate a lot of shad. All right, so this helped to maintain the Revolutionary Army, and this is coming right at the time when the bald eagles are feeding their young. So you got all these fish coming up, mating and dying, and now just floating on the water. Eagles love this. So this is really important for aquatic ecosystems. Obviously, a lot of people are interested in fishing shad as well. We have some bony fish, which are really long and thin. There's pickerel, there's two kinds, and there's pike. Pike are a little bit bigger. The neighboring county in Pennsylvania is called Pike County, if you're interested. So there's a couple different kinds here. Fisher people, like these a little bit, I think, because they get to be big, and it's fun to catch a fish which is 20 inches long. But they tend to be really thin and really bony. So if you've never gone to a restaurant and ordered pickerel, probably a reason. They're hard to eat if you ever try. But they're pretty rapid, and they can be pretty serious predators on other fish. We have perch, okay, and they have relatives called walleye. Perch have a little bit of red on their fins and some striping. They don't get as big as bass, but they are considered a sweeter fish to eat. So a lot of people like eating perch. Once again, they have cousins called walleye, which one can find in our area. Then there are catfish. So fish scales are changeable. Some fish have said, you know what? We don't have to do the scale thing anymore. We can just lose them and just kind of have naked skin. So some eels do that, some catfish do that. And that's now they can kind of get oxygen from the surrounding water through their skin. So that helps them breathe. A lot of fish will have to like move around to breathe, whereas catfish can now stay at the bottom because they're in part breathing through their skin. Because they're coming out at night, they're at the bottom. They have these big sensory barbells, so they can just kind of poke around, and if a water bug moves, they'll feel it better, and then they can go and eat it. They do have spines, which, like, if you're going to handle, catfish, you're going to get stung, and it's really going to hurt later. So they have spines here in that fin and in these fins. The catfish we have in our area are called bullheads, but there's a lot of catfish in the world. Some of them in South America have like really thick bony armor. And so I'm kind of focusing on the fish of Orange County, just running through some of the diversity here. There are 20,000 species of fish alive today. So obviously, we're winding up. We can't do like all of the catfish of the world, which would be fascinating. Some of them are huge, but we don't have time for all of those. Now, you might think that these are baby fish, but there's a group of fish, we often call them the minnows, but there's a whole group that's their adult size, all right? They're not intending to get really big. And so there's a number of different species called dace. So there's black-nosed dace, there's cut-lips minnows, there's red-bellied dace, long-nosed dace, there's chubs, which get a little bit bigger, etc. So we have minnows. Most of the minnows are small. This one's a little bit bigger. It's a shiner. known just because of its extra shiny scale. So shiners are in the minnow family. Okay. But then there's a minnow that gets even bigger that's called a carp. Now, this is an introduced species. It's not native to Orange County, but you can find it in Orange County. And they can get to be really big. All right, so they have a mating season. It's early spring, and all of a sudden you might see all these big fish thrashing around. That would be the carp. A lot of people do eat them, not so much in the United States, but I've read that in Europe, just the market for carp, the amount of money exceeds what we spend on salmon. All right, so that a lot of people eat carp. At least that's what I've read. So it's an invasive species that was released here. It's in the minnow family, bigger than most, but that is one of the fish which we have in our area. We have one family of fish, which we know very well because they're common in lakes in our area. These have the sunfish, the crappies, and the bass. There are two main kinds of sunfish, and a couple ones you're less likely to see. One's called the bluegill. They're kind of like a darker slatey gray. Okay. But then there's another one which is called the pumpkin seed. That's just a bit more colorful. All right. So we've got, there are a couple other kinds, like if you're in a deep lake like Lake Wallenpaupack in Pennsylvania, you might find another one. But pumpkin seeds and bluegills are the main sunfish we have here. Okay. This one kind of looks like a sunfish. It's a little stretched out, almost like a bass. So remember that bass and sunfish are in the same family. And here they have a cousin that's kind of like got a body shape halfway between them. They're called crappies. All right, so there's two of those, white and black, right? But you can find them in our areas. And then among the largest fish in our area are the largemouth bass and the smallmouth bass. Slightly different habitats that they like. But, obviously a prize for fisher people, and these can get, huge, up to, I wouldn't know, but I think like 30 inches. I've been in boats where people have caught really big bass. So I think, well over 25 inches for some of these. Now, as we start talking about, like food chains, et cetera, obviously there's lots and lots of birds that eat fish. But some of these fish get so big that they can eat birds. All right. So if you've got like small aquatic, like ducklings swimming around, and you've got a bass that's like 20 some inches long, I mean, the ducks aren't safe. All right. So, the food chain aspect can go both ways. And then the very last group in our area are the trout / salmon. Now, this is annoying, but I'll just say it anyway. There are words we think mean something, like eagle versus hawk. Turns out it doesn't really mean much, because like a hawk is just a big eagle. Or I'm sorry, an eagle is just a big hawk. And these eagles are more closely related to these hawks. And these eagles are more closely related to these hawks. So these eagles, like golden eagles and bald eagles, they are not relatives at all. Each of them is more closely related to certain hawks than they are to each other. Same thing, salmon and trout, two different groups, right? No, like this salmon is a cousin of this trout, and this salmon is a cousin of this trout. They're all in the same group. All right, we just call some of them salmon, some of them trout. They're not separate groups. The way that salmon migrate and they can swim upstream, and jump out of the water, trout can do that too. All right, they're cousins, and so we have trout in our area. In fact, somewhere in here you can see them. Here are trout jumping out of, you associate, don't salmon do that when they migrate upstream? Right, but trout are related to salmon, and they can do that too. At some point, there's a fishery that I think it's in here, should be. Oh, there's one that hops out on a dock and then is really unhappy and then flops around till it goes back in. All right, that's probably coming up somewhere. Okay. We have 3 trout in our area. One is native, and the other 2 were introduced just because people like to fish them so much. All right, so here we have brown trout. All right, so they're more of a dark brown. They can have spots, often a little color, just like birds. Genders can differ in how colorful they are at certain times of the year. They can be a little more colorful. Fish can be like that too. And so, yeah, this is the one that I think jumps out and is unhappy on the dock. So how colorful is a brown trout? All right. Well, they can get a little more um, colorful at certain times of year. Rainbow trout sometimes have a little pink stripe, but a lot of times they just kind of look a gray, and they're called steelheads. But around mating season, once again, take on a nice pinkish color here. And then we'll see in a second our native one, the brook trout, which I think are beautiful fish. Now, just like if you go birding, you say, oh, here are the birds I'm going to find in a swamp, here are the birds I'm going to find in this habitat, that habitat. Fish are the same way. So if you're going fishing and you want to catch a bass, like a lake is a really good place for that. But if you want to catch trout, you're probably going to a river. All right, because trout need just higher oxygen concentrations. So, lakes aren't really going to give them the oxygen that they need. So here's the brook trout, and at certain times of the year, they've got that nice red coloration. I think they're a really attractive fish. Okay. So as I wrap up, just the thought was after last semester where we took one group and just kind of focused just on birds and all kinds of birds, was that there's so much other cool life that exists in our area that we can enjoy seeing in and of itself, or whether it be humans feeding on trout or just the birds that we like so much, involving them in the food chain, just understanding life a little bit better. And I decided to add in kind of the fossil history, because once again, I'm a little egotistical when I say that, when I say this, but I'm interested in me. And when I think about human anatomy, I love seeing like, ooh, here's how much of it was in place before the first fish. Here's how much was in place in the first fish. Then we get the jawed fish. Then we get the bony fish. And next week we do the amphibians, the reptiles. I don't know if you see where we're going. We're going to end with us. All right. And that's, once again, I know there's a little self-centered, but just being interested in where did my body plan, come about. And it turns out it's, hundreds of millions of years in the making. And I enjoy watching that slowly build. But in any case, 500 million years ago, 550, there were no fish. But then there were fish, all right, coming from a group of invertebrates that started off with fish, with some fish features gradually getting more. They were jawless at first, all right, but then tens of millions of years later, they developed jaws. Tens of millions of years after that, another group, the bony fish, developed. They're not all that big or creative at first, but then, especially after the extinction of the dinosaurs, they really diversify. Most of them opt for maneuverability, and they make up most of the fish alive today. But there is a second group that I didn't really mention, and this is the group that develops lungs. And I didn't mention it because we'd like to get back to them next week. Start off with the very few of these that exist today, but then get into the first amphibians, and then get into the frogs and salamanders that we can find in Orange County. So thank you so very much for coming. If anyone has any questions, feel free to stay. Otherwise, next week we are doing amphibians. Yes, you had a question. No idea. I have no idea. Does anyone know?
Big eyes.
Big eyes? Oh, okay. Thank you. So this is, I feel a little bad giving this lecture because in my life, I have fished a lot. I have caught very little. So like I'm a fisher person. I suck. I could go into stories. We don't have time for the stories about how bad of a fisher me, my brother, my friends were when we were growing up. So yeah, anyone else who wants to help field some of those questions, feel free, because did someone else have a question? Yeah. So good question. And if I were to plug my own music, which I obviously shamelessly. So the fish do develop things like just our brains are huge compared to any invertebrate. So you look at brain size to body size, just absolutely huge. Hearts, like you look, like a heart is essentially just a blood vessel that does this every once in a while. So other things like crayfish have hearts, like some things do have heart, like earthworms have hearts. They're just blood vessels that do this. Whereas we have like this big kind of compact, robust thing that's really going to get serious about that. So like vertebrate hearts, including the hagfish hearts, just so much unlike the the other things. Another, we could get into things. There are things called neural crest cells that only the vertebrates have that make up a lot of our fancy head features like eyes and ears that no invertebrate has. A big thing, I mentioned it in a song, there are genetic accidents. There are mutations. One of the kinds of genetic accidents that happens more often than you think is just every now and then you get double the number of chromosomes you should. All right. Now, with most animals, including humans, when that happens, it's fatal. Like humans, or almost always fatal. All right. Humans don't survive it. But if you look at why is this gray tree frog not the same species as this gray tree frog? It turns out, oh, this one has double the chromosomes as this one. If you look at why is this toad a different species, this one has double the chromosome. You go in your grocery store, a lot of the foods that you ate, a lot of the plants you buy, they're what are called polyploid. They have extra sets of chromosomes. But at the base of the vertebrates, it seemed that happened where the chromosome number doubled in an accident. And at the base of the jawed vertebrates, it seemed to happen again. So part of your answer to your question is we've got more genes than the invertebrates do because they doubled here and then they doubled again. And now when you have double genes, you're like, ooh, we'll tell you what, this gene can do what it always used to do. But now I got this extra copy. Maybe I play around with that experiment. Let's have it do a little something so in your genome, you don't just have globin. You have alpha hemoglobin, you have beta hemoglobin, you have myoglobin in your muscles, you've got neuroglobin in your nervous system. Once there was just globin, period. But then duplicate genes say oh, let me do this one with this one, this one, this one. So at the base of this, that extra genetic, complement, I gave just them the ability to experiment and do some more things. Good question. Anybody else? Yes.
But if every individual is a double number, it can't mate with any other individual in that species.
So I want to say absolutely right. You're almost absolutely right. With mating, just you never say never. If you say, oh, mules are sterile, horses can't, that's mostly true, but every now and then you can get a mule that's fertile. So with that, can you mate with these things? You've got different numbers of chromosomes. Usually not, but every now and then someone will say look, here's a kid from these two. Who would have thought? Especially when we're dealing with simpler things, a lot of these can fertilize themselves. There are fish which never mate. It's just all females that can mate with themselves. Even some frogs, even some snakes and lizards. So they're parthenogenic. So that can happen. A lot of fish can change gender over the course of their lives. So if you've got siblings that are kind of like you, and now all of a sudden some of them are male and some of them are female. So with some of these more primitive organisms, there might be some more options with that, which is why it's a little more common in fish than you would see in mammals. Plants, it's very common. Polyploidy is quite common. Animals, it's rare, but it happens enough. So it's a very good question. But when it comes to, can these two things have sex and have kids? Sometimes it's absolutely yes, sometimes it's absolutely no. There's a whole lot of usually not, but every now and then you have this workout. So sure. Yes, forgive me. I think I'm not positive where I put this last. But you might, I'm sorry. As you leave here, I'm sorry. So here's a fish skull. You can see some of the big teeth. Here is a lamprey. I'll just leave them on the front desk. Here's a lamprey notochord. If you want to leave, you can actually see the little pumps of cartilage. I'll put a bowfin skeleton out for another one. And I'm sorry to interrupt your question. I just figured rather than hear me explain it, you could actually look at it. But yes, your question.
When you see a feature like that, how do you discern something that's been lost secondarily, like those early? How do you know an ancestor that have more or now?
So, yeah, no, excellent question. So one, if you can find a fossil that then says, ooh, the ancestral state had this, that helps. But with softer tissues, obviously that's a problem. So what you would try to do is ooh, can we take a lamprey or a hagfish and can we look at their embryos and see is something starting to develop the way that I once had slits here, I had a notochord. You could say, oh, his ancestor had those features even if he doesn't. You would try that. But for example, this is something that bothers me because I teach anatomy and genetics. I don't know who to side with in this fight as far as, are the anatomists right or the geneticists. One of the things I read is that hagfish, so later with primitive sharks, you've got cartilage above the notochord, but then later you start to get a little piece of cartilage below the notochord. And then they'll get bigger and fused. So now you've got top parts and bottom parts. Now you get a big vertebra. I read once, I'm not positive, but lampreys, they've got the top part above the notochord. Someone said, you know what? I think I'm seeing in hagfish, I think I'm seeing a little piece of cartilage below the notochord. Which then raised the question, so maybe what I thought was a shark thing, an early shark thing, where you've got cartilage above and below the notochord, maybe that goes back to the first fish. Lampreys kept the top half, hagfish kept the bottom half. But that would be an example of, it's kind of hard to piece together. So you do, histological studies, you study the embryos, et cetera, and hope to piece it together. Good question. Thank you so very much for coming. Have a wonderful evening. Thank you.
It's good.
Hi.
I wanted to ask you, did you see any owls that day in the Liberty Loop?
I saw yesterday, yeah.
Oh, yesterday. I did.
Yeah.
The day we went out, like last 2 Mondays ago.
Yeah, we did. Yes, we did.
I saw them at the very end.
Yeah, towards the end.
Whole different flight pattern.
Yeah,
That was very cool.
yeah, they are beautiful birds.
Good stuff. It's very informative.
Oh, good, good. I'm
Great
glad.
presenter too.
Oh, thank you.
Cool. Take it easy.
Thank you, you too.
Did Amy come back for the birdhouse?
She has not yet. It's still in my office.
Oh, okay, he probably not gonna make it until the spring, maybe. He's probably busy,
Okay. Okay.
all right?
If I hear, because we'll do walks and stuff. If I hear that she's coming, I'll bring it.
Take care.
And thank you for that student's wallet.
Did she get that,
I told her I'd be teaching in this room, so she did not come. So
you'll take care of it?
yes, I will.